are going to talk about composable architecture and paradigm shift in delivering software. My name is Azad Imamoglu. I'm a managing architect at Netcompany and working nearly 15 years for Netcompany, Netherlands. I have been working at public sector especially. I started at Netcompany as a junior developer, and in time we had many challenges and very nice challenges, by the way. And right now I am here in front of you and together with my colleague Carina Cornet.
Hi. Yeah, so I'm Carina. I started at Netcompany last year after graduating my computer science and engineering master. So yeah, I'm a software engineer, consultant. I started also on a project in the public sector for primary schools. Yeah, I'm also enjoying it very much.
We are working for Netcompany. If you this morning already followed keynotes, probably you have seen those slides. Those are very known slides for you. Netcompany is company especially working for the public sector, especially in Netherlands, working for the public sector. We are building custom software for ourselves, let's say, as citizens of the Netherlands. Our headquarters is in Denmark, and we have also in several European countries other offices also. The agenda of today will actually talk a bit about the state of the software delivery in the public sector right now, very shortly, and composable architecture. My colleague will take you in composable architecture structure, and after that we'll wrap it up and then talk about shifting the industry towards composing together. Now, we have been developing the systems for scratch for the decades, and right now it is time to do a change. That is why we wanted to also share our ideas, not just as a company, but as a person, as a citizen of this country, but also iemand who is living on this world. Copy and paste programming, don't repeat yourself, rule of three. Those are most of known thing, I think, probably for most of you. Once you are developing, you are thinking like, today I am busy. I'm not just thinking so deeply. I am not busy with analytical work, or I'm not busy with algorithms. I'm just knocking code. It happens many often because we are most of the time developing the same and the same and the same code again. What we are doing once we are building software. To build a better software, actually, there are several things needed. And the most important thing is actually don't repeat yourself. Try to make the quality better, but I would say right now what we are doing, what I have been seeing from my experience, we are building the same wall over and over and over again. Of course, we all have our own repositories. We are using NuGet, so we are using also open source applications, open source packages. But at the end, still, this is the same application, same things being built for the same customer. I cannot imagine, once you are developing, no one of you have faced this problem. We don't want to build anymore the new walls, actually, as developer. From the developer perspective, I would like to build actually the new pieces of bricks, and I want to be busy with other kind of things, other kind of application than only administrative application, which are just doing CRUD work, taking the information from the database, bringing it to the presentation, and from presentation again back to the database. I think this is also what all of you wanted to do at the end. So, what would you like to develop as a software developer? That was a question to myself. When I was just creating this, I was thinking like artificial intelligence, machine learning, deep learning, robotics, maybe new programming language, working on compilers. I don't know, it depends on what you like, but I think those are, for everyone, the catchy things. I wanted to be busy with those. Yes, all of them. At least that is for me. I would like to build all of them. But at the same time, we know that we need to also think about the finance, because not all the applications are working only with artificial intelligence. Machine learning, if someone says, we are only building this, of course, besides robotic companies, for example, we are all the time busy with those things. No, you are most of the time busy with also administrative things, what you are doing. What we need to build, actually, I mean, and most of the time those are crowd applications. We need to automate the world. We know that, especially after the corona. We have seen that any company wants to be automated, so they can also work from home, not only from the office. So we have a big challenge. There are not enough software developers, but at the same time, we wanted to, as software developer, also build new things. We don't want to build all the time all the walls over and over again. How can we avoid this problem? I think we can avoid that with building bigger pieces and make it publicly possible for whole humanity, I would say for whole world. And when somewhere it is needed, then we can use those. And instead of using your time building the same application again, you will just reuse this. But it is not so easy. That is, I think, everyone's goal. Most of you wanted to do that, but it is not working because each time it is custom work coming there. Let's take the public sector as a case study. That's why we wanted to further go deep into it. How are tenders published to the market? That's the most important thing, because we first need to see what is happening at the public sector now. I will not just go further deep into it, but when the public sector wants to build a new application, they are bringing it through the tender net and a new tender. And first they are starting with consultation, of course, and then after consultation there is an announcement phase, and companies are reacting on it. It is a bidding process, and there are functional and non-functional requirements, and only thing what you need, actually, you are answering those functional and non-functional requirements. And at the end, there's an evaluation and the contract award process. And at the end, you are getting contract, you are starting to build. How does the execution phase looks like when a company just win this award with this contract? At the end, actually, you are again building the same thing somewhere else. In my practicality, what I have seen at the project what we were working, they never said, so you know what, for this public sector, we have built an application and we know that there is at Belastingdienst or UWV, anywhere, there is an application, we want you to reuse those components from there. It never happened to me, at least, past 15 years. What are we doing? We build the same wall over and over again. That's what is happening at the end. But why we cannot do it? Why it is not working? Let's take the composable architecture as an answer. I think that is the answer for this, but why we cannot connect those pieces with each other? Why we cannot just connect like, it is very nice that you are hearing, okay, we are going to create Lego pieces, we will just put on them on each other, they will just perfectly work. It is not working. That is not, at least in our practicality, when we are building a software, we never have seen software components that we are clicking on each other, and there is a new application. By the way, don't mistake, I'm totally not talking about no code or low code. I'm totally talking about like building your own custom pieces, either by .NET, Java, or Python. It doesn't matter any language, but totally custom components. That's what I'm talking about. And this is happening at the car industry. Why can we not do it? Because we know that car industry, they are right now, they are using the platforms to share the components, sometimes very large components between the models, and sometimes even between the brands, because most of the car companies are like Volkswagen. Almost the half of cars, what we know, are belongs to Volkswagen. But they are reusing those parts. So it means that it is possible. It can also happen because they are also exchanging sometimes the same platform with another brand. How can we build software platforms to share large components? So we wanted to actually do the same what they are doing. And I'm giving word to my colleague, Carina, which we will take you a bit further with that.
Yeah, so I want to tell you a bit more about the composable architecture we've been talking about, because yeah, it seems like the perfect solution. And it is a very good solution, let me tell you. So the composable architecture. First, I want to make clear what we're talking about, and I'll do that by further extending the car example Azad was just talking about. So initially, we had the small workshops, and then a customer would come into a workshop and like, yeah, I would like a car, I need these specs, so many people should be in it. The car would be custom made to fit the needs of the customer. This is very time consuming, of course. It was also very expensive. So when Ford came with the belt system, they could mass produce cars. All of a sudden it went much faster because you have one design, you have a plan, you have customized workers, and it makes it much easier. Because yeah, the components are basically the same, all of it is just the same. But yeah, then the downside comes back in, which was not a downside before, that the individual needs of the customer are not met. If you want a larger car, a smaller car. So this is where the current car industry is the perfect fit. It's the best of both worlds. We have the components, the modules from the basics of a car that are shared, but at the same time, we can also optimize or customize the cars to fit the needs of the customer. So this is actually the fit that we want for the software industry. So can it also work in a software as service model in this world? Well, we think it can. So composable architecture, we have 4 main core points that are important. We have the modularity and autonomy, discovery and orchestration. And afterwards, I want to talk a bit more about uniting these business needs and what it looks like. Composable architecture was actually mentioned by Gartner. I don't know if you're familiar with it. They analyzed technical trends for the year 2021. They saw that this is needed. Composable architecture is needed to change, to keep allowing change and growth despite the persistent uncertainty of things. And if you're ready for this change, then it doesn't matter. Then you don't have to take high risks when you do these or implement these changes. So when we're in an industry that's continuously changing and growing and there's new demands, then we need to be in an environment where we can continuously implement these changes. And yeah, we have enough programmers to do these jobs. So it does not work if we keep redoing our work, but rather we need something that's safe, fast, and efficient instead of reusing everything we already have. So let's talk about these 4 core principles to show you what I mean. So first we have modularity and autonomy. So modularity is more the partitioning a domain into managed components. I think we're all familiar with it because atomic design is widely used in web design, of course, already. So Brett Frost introduced this principle. He learned it from chemistry. So we started atoms, the smallest, well, not the smallest, but the small pieces that we know that build up everything. For example, a text input field or a label. And these then make up the molecules. If you combine a label and a text input field, and then we can combine these multiple molecules into organisms. And these organisms we can put into a template, into the context of a template, and actualize the templates in pages that are needed by the customer. So each of these components are autonomous. So we minimize the dependency of components from each other because we want to maintain the integrity of change. We want to be able to make changes without breaking everything. So what does this atomic design look on a architectural level? So we have the same principle. We have atoms, but now instead of single text fields or labels or buttons, we're actually introduce them as microservices. So for example, a document management system or a customer or a client management system or a payment system, these are all microservices. You should be able to connect to any application you need. Each of a microservice has its own purpose, is modular, and should be autonomous, with of course communication between other services. But then these microservices can be used in applications. So for example, if you have a billing system, then you would need a document management system, you need a payment system, you want a database for all your clients and stuff. So yeah, these together form the applications. And yeah, of course, you have a bigger platform a company uses. They not only have billing, but usually also sell other stuff which is in the database. So you have this whole platform that's used. But yeah, if you have one company, that's not the only company that sells stuff and uses billing uses this billing technique. So we should be able to make templates for the products that we sell. And yeah, then the template is then customized, so the user or the end user, it is suitable for the end user. So here we reuse this atomic design, but bring it to much larger level. So what does it look like? For example, with Azure Kubernetes, this is so easy because you just run your individual services into pods, and this containerization. This has the added benefit of that you immediately have this containerization. You have an enormous amount of flexibility because you can scale up pods that you want that need more power and scale down that's not needed. If you don't need it at all, you can easily turn it off. So scalability is a big plus here. So let's move on to the next core component. We have discovery. Because we need discovery. We need the ability to discover and understand design opportunities and components. Because if we're not stuck designing the same things over and over again, then what are we going to do? So we need discovery to guide, track, and secure this change. So we need new ideas to improve our current architecture, our current application environment. We can make more complex systems because we can build up on what we already have rather than starting from scratch every time again. So we need to expand, optimize, improve, and make new combinations in this architecture landscape. And composable architecture is a perfect solution to this. So we should be able to see these opportunities and discover these new components. We need to start discovering again rather than just building. And we already see this in a couple of companies in this, out there. So we have some out-of-the-box solutions. For example, Linux. Don't know if any of you are familiar with these. They have software as a service and they help organizations to analyze and plan their architecture in order to build better products and so succeed in the digital transformation. So they have this expandable inventory, and they have like a browser and an app. So the user would just be able to choose what suits his or her needs, which sounds a lot like composable architecture already. Then we have OPS level. They have this so-called modern service catalog, and they aim to organize the services used by an organization. So they want to collect it to improve the efficiency, to know immediately what goes wrong. You have to to eliminate single points of failures. So they also want to optimize on this. And they also have Cortex. This is the first integrated intelligent automation platform. They provide complex event management, machine intelligence, and processes on a single platform. So they also combine this, and you can also customize how you want it. And the last one is Bit, which is a cloud-hosted collaborative platform for UI components. They extracted the UI components, and then you can reuse them. So this is more on a lower level skill. So the last core we have is orchestration or cataloging. So we need alignment. We can't just decide tomorrow that we'll all work together, because then we need some kind of standards. We need to make some ground rules. Team project doesn't work without some ground rules, of course. So prescribing and negotiating interaction between components to enable the recomposition and forming of processes. Because if you have all these components, you still need to be able to combine them. So that's where the prescribed interactions come in. The open standards, API standard first approach works really well then. But we'll hear more about that later from Azad. So now that we've seen what the core principles are, why should we have to deal with this? So there are some key benefits that we, the customer, that everyone gains from this composability. First of all, we have this enormous flexibility. We can pick and choose any module we want and create new systems. This is kind of like your own sandbox. You can just make what you want and create the perfect solution to your needs. Secondly, we have the best of need. We reduce complexity and we pay only what we need. You probably have some of these licenses that come with a lot of extra things which you actually don't need. So this actually reduces these costs to only pay for what you actually use and need. And then we also have the rapid innovation. Building, testing, and releasing can be done more rapidly. Instead of being stuck repeating, we can continue immediately. And it also creates more independence because you don't have to deal with all the monoliths and the legacy buildup. These components are very flexible. Change should be important and should be doable. So you're not a vendor login, which makes it a good solution. And lastly, we have it also benefits the business IT continuum because they will be better aligned, and we will be able to make better applications. So I found some companies online that already do this. So we, for example, have the MHC8 Alliance, which is a microservices-based API-first cloud-native software as a service and headless. So the same as Gartner, they also saw this trend that it is important to embrace change rather than fear it or calculate every risk. But change the beginning principle. Introduce these new ways of thinking about business. And they help companies to take advantage of the most innovative and flexible enterprise. And then we also have Point 3 Days is a web series of podcasts, and they talked about Swift, which can be made into a composable architecture. And in these series, they set up this GitHub library with a lot of composable components, which has actually been updated like 4 days ago, so they're still doing that. So that's also an example, and we already saw the examples I just mentioned a few slides ago. So we clearly see a shift already. And I want to talk to you a bit about what we've been doing at Netcompany. So we we made Modulus Case a few years back, and we have been able to implement this in a lot of projects. So this is a case management system, and so for each new action, each new user, you make a new case, another user for a system, for a person, you make a new case, and then through automations and specific actions are required from the user, but every other process can be automized. So for example, if they have to send reminder emails or have to do some filing or making some reports, these can all be automated and don't require actions from a user. So they try to limit the actions by the user and make it as efficient as possible. So for example, the picture on the right is for a social children system in Denmark. These users don't want to be stuck on a screen all day. They want to help the people, and having an efficient system helps them. So the user has a clear overview of the actions that are required, and also the statuses of the current cases. And then it's also very easy to make custom views for different users. For example, the top one is for the team leader, so you can have an overview. The other one is more about the cases that you can see. So this is a Modulus Barn, which was based off a system it was initially made in Norway, and then Modulus Barn is a adaptation for that for a system in Denmark. It's a joint municipal IT system used by the child welfare services in a majority of 98 municipalities. So they found out that the current system wasn't really working. It was not secure enough. The children weren't getting the help they needed. So they needed a new IT solution, which was more secure. And that's why Modulus Case is a perfect fit. And Modulus Case has a lot of, you can use a lot of different texts for this system. A lot of possibilities, of course. And a slightly different case management system is the grant management system, to give you more of an architectural level view. So this is also cases-based, but then for grants. So you have the self-service, which of course the interface with the application administration and the grant administration, but then you also have the budgeting, which is like the background, the scheme call and route administration, and overall you have the configuration, functionality, and the cross-cutting concerns. And if we look at the cross-cutting, so these are all kind of separate components, but if we look at the cross-cutting concerns, they split up even further. Because of course we have user creation, permissions, authentication, fraud detection, version history. So all of these things are important when we have an application. And to give you an idea how large it is, we have all of the components here again, and on the right you see the cross-cutting concerns. But there's so many components that form larger components and that form the final product. And to build it up even further, over the years we have just developed a lot of these systems, and finally made it into Golftec. This is a unique delivery model. We have more than 250 solutions that can be used in any country, really. 2,000 components. So real solutions to real problems, which can be combined to whatever is required. So to give you an idea of what systems are involved, we already saw the Modulus Case platform and the Modulus Grant platform. There's also a benefit platform, a citizen mailbox, a registry platform, which we also use in the Netherlands. So there's just a lot of different components that, of course, every municipality needs in even multiple countries. So we want to unite these business needs, and then we want a solution that is composable and extendable. Because when solutions are composable, then changing is less risky, and we can further improve our current systems. So, for example, say you want a new document system into an existing application, then it should be very easy to just introduce this new component. You follow the rules that were set up, and then just connect it to the current system. We also want it to be composable to make the system, and then extendable to add things you might not have initially thought of, but still want to add. So, for example, in the UK, you have a cloud delivery support. So the goal is to insource the legacy code to the modern technology platforms. So to transition the legacy code into something new. And they also have a state pension and disability benefits that combines the two solutions. First, the Modulus benefit platform and the Modulus Case platform. So into a new solution that is perfect for this situation. Two other examples we have. So there's an injury claim management platform. Existed of a lot of legacy code today. They've replaced it by 3 solutions: the Modulus benefit platform, the Modulus Case platform, and the Get Organized ECM platform, which is a Microsoft Office award-winning platform to work with documents and stuff, and an unemployment platform, which also uses Modulus Case and benefit, and also combines it into this Modulus unemployment platform. So really reusing these components is so important.
So how is it different from low code or PPM?
It is on? Yes, right. Difference is like, that is actually the key answer, and that is the question, actually, key question that we are asking ourselves. How can we generate modules that can connect with each other? When you are looking to the, exactly to the low-code platforms, those are most of the time, I don't want to use immediately that word, but it is from here till Tokyo, that is the way how we Dutch are saying. You are actually connected with that company and you cannot go out. For example, we did also research about, can we use the low-codes for this, low-code companies and different low-code platforms for this. But once you are using one platform, it wasn't even possible to have your own data center, and then they were saying, okay, we can do it, but you need to do this with our engineers. That is the difference between the low-code and this. It's not like that we are saying we are going to put in the low-code. When you are doing in the low-code, you are going your atoms, that's what my colleagues were talking about, services. Atoms are much, much, much smaller. We are not talking about smaller atoms. We are talking about services as an atom. So we are building, for example, there are many examples of this. For example, an CMS system. There are many open source CMS systems, right? This is an example of that. There's a component, you can take it, you can reuse it somewhere else, but in case that you wanted to connect this with another component, for example, you wanted to connect an CMS with an DMS system, at once they cannot talk with each other. That is the level what we are talking about, and that is the biggest difference.
And now with this they can.
Yes, I will, in a moment, I will talk about that, and exactly, they can talk with each other. And those are bigger, much bigger modules, and those are much bigger components, and then they can talk with each other. And that's the biggest difference. But yes, those are all made by our company, but my main question will be, in a moment, why my component cannot talk someone else's component, and what is needed to do that. For example, I have two kids. I love to play with the wooden trains. We have at home, I think, from Brio, that is if you have kids, you know that, or maybe you also like wooden trains. I have at home Brio, Mattel, IKEA, and even some trains from Lidl. Did you even realize that you can connect all those things together? They are working. And why my module is not working with one or CAP, CGI, Microsoft, any other company which is actually creating? Why they cannot talk with each other? That is the main question. That is actually right question, and the paradigm and the shift that we wanted to actually bring over.
But then the reason you just brought in why it's not low code, it contradicts with what you're saying. So you're saying we just built a new low code platform, but it's big.
But I'm saying this is not low-code platform. This is actually components. What I want to just put there as that open source, built with modern technology, and that's that modern technology what my colleague was talking about. Everyone knows that, and everyone can use also this. And that is the biggest difference, actually. At this, I'm just putting there somewhere else. I wanted to put it there. This say to, okay, this is for the whole humanity. You wanted to have a wall, I'm giving you free wall, but I want you to put your effort to create new bricks, and then share that also with me, so that we can together bring this to the new level. The other question?
Yeah, so basically, this is not a new problem to when we talk about software development, but then there are so ifs and buts, like trade-offs. Like for example, if we create a ecosystem where each company, whatever components each company creates, and that they can talk, so it also means they are, it will take long time whenever there is some innovation, because then you have to follow some rules and regulations, because if you communicate, then you should have some protocols, right?
That is exactly what we are talking about. That is the thing. We are not talking about something new thing. Huh? We are talking about an ideal world, but still we are not living there. And why? And that is actually the question. It is not that we are talking about a new thing. We are just talking about our experiences to create this. But the next question, why this is not working with another module? And that is that, how can we reach that? And what can we do as developer to bring to actually change bring the shift in the mindset and go to the next feature, and the next feature will be like my module will be working with everyone's module, and what's needed to do that.
But then, like, at the start, you have given examples of box level, like they can create a components of car, but those components also being shared with their subsidiaries. For example, box level, Polo, you can have same components as for Arcadia, which is their brand, but it does not make sense, like it will share with Suzuki, because then it will end up the competition in the market.
There are examples which are working, especially there was, for example, if I'm not mistaken, it was Renault Traffic, Ford, Renault, Opel. Afterwards, Opel was also became part of Peugeot, but still they have working together. They have shared some small autos and some company autos. They did that. They were working together, and it was working. So there are examples of that. But that is just, those are, I mean, I was using Turbotal, so putting some Dutch words in it, but this is actually the questions what we are asking you, and the idea, this is not something new, everyone wants this, we know all of that, we just wanted to point once more what is necessary. Where can we start with? That is what my colleague trying to actually tell you about, how we have done it, and in a moment I wanted to actually ask you some questions, and those are, and that way we'll just close this session. I'm just looking at the time because I don't want you also. Okay, we are running almost out of time.
Along with the examples. So we want something that's composable, extendable, scalable. Need something that's up to date, of course. Something that's easily implementable and adaptable. And then, yeah, of course, there's some challenges, and Azad will tell you more about that right now.
Thank you. It's actually right questions before we are starting with this part. It was also very honest and once more right questions. What are the challenges what the industry right now facing? So to connect all those things together. To start with, to build the components that fit for a composable architecture, those components needs to follow some requirements, and they need to be, for example, robust and resilient, so that you can have on long term and components what you can reuse. Of course, you can think about versioning systems. You can bring some versionings, those versions can work together, etc. That's at least how we are doing. The example what we are giving, what we have done can be also done by whole ecosystem. And when we are talking about ecosystem, actually the whole world, all the IT companies which can work together. And it doesn't need to be, for example, once you are creating those components, any component written in some certain language should be connectable with another component written in different language. We need to follow the best practices. So consistent use of good software engineering practices, that's very important. That is to keep, of course, in a moment I will say about quality and assurance for that, because once you are using the best practices, you know that it will be also qualitative, it can be reused, it can go further. The user interface design is the biggest challenge, I think, because how can you bring some user interface design which are modular, but we have great examples for that. We achieve that, so why we cannot all achieve that again once more? Maintainability, and that is especially important once you have it. It needs to be written in some language, and that is the most important, what we were also talking about. If I'm writing here something, I would like to write something which is being used, for example, talking about websites. When I'm going to use a website, I want to use React or Vue.js or Angular, because those are top 3 languages which are right now being used, especially when we are talking about web design. When I'm going to write this in some language which only I understand, and you cannot maintain this, so we cannot give this to community. I can give this to community, but community cannot do anything with that. So we are running out of time, and I will just finalize this and wrap it up. Shifting industry composing together, what do we need for that? Everyone thinks about that. This is all our dream, we know that, and there are certain movements, also there are some things what some companies tried, but still it is internal. For open standards, we need to have first open standards to connect those together because we have the same model. When we are talking about person, in mine component, a person needs to be the same model elsewhere. We need to bring governance to this. We need to bring governance when we are talking about an ID. The best example for this is, for example, ADAS. I don't know, either you heard about this, the European ID solutions. So right now, we are working on this. Some countries are already done with that. Netherlands is still working on it, but it can accept also from outside. You can, for example, log into a Dutch municipality just by using your DigiD or e-herkenning. Why it is possible? Because it was like the regulation has been done by European Union and everything was set as, was governed, how they need to connect with each other. They were not talking about this is component, those are components, what you need to do. No, they were just saying this is an ID, this is a person, the person has those metadata, etc., and those are the APIs should work on that way, and that's all. After we have the governance, we can create open source components, and once we have open source components, we can bring those components to the community and put it actually somewhere. It is free, everyone can use it. And once there is a community around this, that community will create also a new features, will bring new features. Think about Linux, exactly the same thing. Just bring something to the market and make that community helps you to grow this. And at the end, it will then become one of the most trustful OSs on the world. We all, I think, use also Microsoft, but we know that Unix, very old system, once based on Linux, but let's say Linux is actually, in my opinion, that's again my opinion, don't judge me, it is much more secure than Microsoft Windows. So to just do this, that is the most important thing. How can we change that mindset? I think it can happen like we are expecting that governments needs to do that. We know that, but governments doesn't have, the people which are making law doesn't have enough experience and to understand what is happening here, what is happening there. What we can do as single developer, just think about that mind. As an evangelist of this, just talk about this in your projects. Try to bring it, make it a low-hanging fruit. Make it a low-hanging fruit for everyone, that everyone will understand that we want this, but why it is not happening, let's, with all of us, try to work towards that. At the end, once it's low-hanging fruit, I think that governments will also start to bring those regulations and make it possible that connect them together. I'm saying in this case governments because I believe that if governments have done this with AID, for example, with ADAS, they can do also with any other things. Thank you very much. And if you have any questions, I think we are just on time. If you have any questions, you can find us at Lot 6. We have there also a bike hanging in the wall, at the wall there, and you can just scan and then leave your information behind. We promise we are not going to spam you. We are not going to give you share your data with anyone else than our company. Thank you very much.